Alright, so this is the case of a normal revolution. Now, revolutions normally last about from 0 to about 4 months. And while we're having this revolution, there's always going to be an increase in population, which will be represented by the equation y equals the square root of x, which will look something like this. And so since it's 4 months, we're going to cut off at 4 months. Now, to find the volume of this revolution, we're going to rotate the equation around the x-axis. And so, in order to do this, we're going to cut it up into cylinders. So we're going to find what the radius will be, which will be y, and what the height will be, which will be dx, which is the change in x. Now, since this will be rotating, it will become a cylinder. So we're going to use the cylinder equation, pi times r squared times height equals the volume. So we're going to plug this into an integral. So it will be the integral from 0 to 4 months of pi times the radius squared, that's y squared, times the height, which will be dx. Now, see how there's an x and a y? That doesn't really work. So what we're going to do is we're going to look back at our original equation, and we see that y equals the square root of x. So we can just change this to, from 0 to 4, pi times the square root of x squared dx. Now, there's a few things we can do to this. If we move over to here, we can take the pi out, since that's a constant. And the square root of x squared is just going to be x. So those cancel out. So we have x dx. And the integral will then be pi times x squared over 2 over 4. So now this is just normal solving of an integral. So we're going to put pi on the outside, and we'll plug both these in, starting with the top. So we're going to have 4 squared over 2 minus the bottom, which will be 0 squared over 2. Now 0 squared over 2 is just 0. 4 squared over 2, 4 squared is going to be 16, divided by 2 will be 8. So that will then be 8 pi units cubed will be our volume of this revolution. Now, this is just a normal revolution, mind you.